Hi everyone. Thank you for being here. I hope you're having a great conference so far, and I know this is the last talk before lunch, so I'll keep it quick. I am kdeniz. I am a backend engineer at Epify, and today I will talk about how to scrape websites and give context to AI agents. So let's start with GPT-3 training. LLMs are trained on vast amount of data. Here we can see some of the sources. Common Crawl is a non-profit foundation that is scraping the web every month. So they have billions of web pages scraped from 2013. WebText2 is a dataset OpenAI generated themselves. How they did is like they went to Reddit, they took posts with 3 or more upvotes, and if that post had a link, they scraped it. Books1 and Books2 dataset for books. Books1 is not licensed and Books2 is licensed. And there is Wikipedia, to be more precise, the English dump of Wikipedia. So now what are some problems with LLMs? Well, there is the cutoff date. Every passing day, the data of the LLM is getting more and more outdated. Then there is hallucinations. We all know it, we all seen it, nobody likes it. And then there is the coverage issue. Because the AI was trained on such a vast amount of data, it is sometimes hard to find certain facts in its training data. Well, this is where retrieval augmented generation, or RAG, comes in, which allows the LLM to query the context and only receive the most relevant information. It looks something like this. This is a very simplified explanation on how it works in the prompt. We have a system prompt. You are a friendly customer support agent, and you know this. There is the external knowledge, which is retrieved by RAG, and then there is some user query, followed up by the end of the system prompt. Please generate an answer for the customer. Well, now we have the LLM, and we have a system to feed LLM relevant context. We are just missing one thing. The data. And the web is the biggest open source data source out there. And we can use web scraping to scrape data from it. But the issue is web scraping is getting more and more complicated every passing day. There is dynamic web content. You curl a website, the content is not there. Well, how we can work around this? We have headless browsers like Puppeteer and Playwright. Headless browser is a browser without the UI, as the name might suggest. It's more expensive, but it's the only way we can work around this. There is blockers. In the scraping world, there is a saying, if you have seen the CAPTCHA, it's almost game over, because they know you are a bot. How do they know? They know your IP address. They know you don't have the correct fingerprints. So for this, we can use proxies. And one interesting proxy I learned at Epify is the residential proxy. It can be anyone who allows their phone, tablet, or laptop to be used as a proxy so that our requests goes through their device, hiding that we are a bot. There is browser fingerprinting. When a browser makes a request, there is metadata about which browser it is coming from, what language the browser is, which can prove that this is a human and not a bot. At worst, we have some CAPTCHA solving solutions, but it should hopefully be solved by proxies and browser fingerprinting. Then there is the cookie models. Oh, do you want your cookies? We have all seen it, we hate it, we don't need it for the LLM, it doesn't give any good context. And many, many more. Modern websites don't want to be scraped. There is infinite scroll, geo-blocking, complex HTML. But thankfully, that's where Epify comes in. We are a full-stack web scraping and web automation platform. On our Epify store, we have more than 8,000 tools called actors. This is an old picture, don't worry about the 6,000 there. You can see we have TikTok, Google Maps, Instagram, Facebook, Amazon. Website content crawler is interesting. This is a generic one, so instead of like just LinkedIn, Facebook, it can scrape any URL. So let's go with the first demo. I have here the UI for the website content crawler. Here I have put the events web page, this event, so it's gonna scrape this web page. And then in the crawler settings, I set the max pages to 1 so that it finishes faster. If you don't set it up, it also takes the links in the website and starts scraping them too to give you a more comprehensive answer. So I'll just press start, and just like that, our scraper is running. We don't need to worry about coding or anything else. And in about 10 seconds, we should receive the both text and markdown content of the website. So we can see it's starting, it has started, it's going to crawl one page. And right about now, yes, we have done the scraping and now we have the markdown content. Now we need to make it faster and more efficient. And for that, we are going to use a RAG pipeline with a vector DB. So let's go over this image real quick. If we look at number 1, there is the knowledge base. In this image, it's documents, but it can be long text also. Then we want to take that knowledge base and chunkanize it into hopefully meaningful chunks. And then we feed it into an embedding model, which will turn it into a vector. In the demo I will show soon, it will be a vector of 512 dimensions. And then we store it in a vector database, which will be Pinecone in our example. If we look at 7, that's where the LLM puts the query, and the query is sent through the same embedding model with same dimensions. And then we are doing an approximate nearest neighbor search in the vector database. So we only return the blue circles, which are similar or relevant context. And the orange one is the user query. And hopefully with this added context, our LLM should be able to better answer our question. So now we already have the data source, which is the website content crawler. We need to create a chunk embeddings, store it in a database, and then use it in prompts. That's where demo number 2 comes in. And I will do this on NA10. I'm not sure how many of you know NA10, but it's a great workflow automation platform. You can build nodes like this and build your own workflows. Here it is of 2 parts. The left part is where we take the results and push it to our vector DB, which is Pinecone in our example. So I have just opened a blank Pinecone before the demo, so we will use this one. And here we have a Epify node, which will do the scraping. If we check it out real quick, here the same event URL, so it will scrape that. And then we have the Pinecone with OpenAI embedding model. One important thing is the data loader. The data loader is the one node that is doing the chunking, and it's a very simple chunking. So in like more production workflows, you would maybe do a custom one, but for the sake of simplicity, it splits every 1,000 characters with 200 characters of overlap. And then we will go to this AI agent and chat with the data we have retrieved from Epify. So first I will start the left-hand side. Now it's doing the scraping. We can go to runs and see here that yes, it is scraping. And after it's finished, it should upload the data to Pinecone. So let's give it some time. Hopefully it will be around now that it finishes. We can, yes. Yes, so now we are uploading it to the Pinecone. The embedding model turned it into a vector. And now we are going to chat. So I think we are all wondering the same question. When is lunch? Okay, so our AI agent received the message and then it queries the vector database. It receives here, maybe I zoom in a little bit, here that the necessary chunk with the lunchtime, and it can tell me it is from 12 to 1:25. We can ask another question. Is there a talk about web scraping? If so, who is the speaker? And let's see what it does. So it is checking the database. Again, the vector DB web scraping talk speaker, and it was able to find the time, the format, and everything. So with that, now we have the way to retrieve data, website content crawler, to create embeddings with OpenAI embedding model, and then we have the vector database as Pinecone, and we use it in n8n AI agent. So now I want to talk about kind of the elephant in the room. ChatGPT can do web search. Then why the hell was I talking about this for 10 minutes? Yes, ChatGPT can do web search, but it cannot search on Google Maps. Here it's trying to say like it can search Google search, and maybe there are some Google Maps results, but it can't directly search on Google Maps. That's why tools matter. And at Epify, we have more than 8,000 tools for your AI agents' needs. So let's talk a bit more about Epify. Epify is easy to integrate. You can call your actors via MCP, via a request, or from your code. Epify is well integrated. We are on Zapier, n8n, Make. So if you like any of these platforms, you can use Epify there. And also, out of the 8,000 actors, only a small amount are built by us, and the rest are built by our amazing developer community. So if you are also interested in web scraping or monetizing your code, please check out Epify, and maybe you can also build an actor. And it's actually a great time to build your actor, because we now have the Epify $1 million challenge. So we are very serious about this. Starting from November 3rd, I think we are like 4 days past, so nothing is gone, until January 31st. If you can build a badass actor, you might be eligible for some prizes. So thank you all for listening, and I hope you enjoyed it. If there is any questions, I can take them right now.
You already know when lunch is, so that might be
Yes.
Any other questions?
Do you have some lightsabers in your job? Because I see on the website that we are going.
Can we just repeat the question so it's on the recording, please?
Do we have lightsabers at the office? Well, I bet they have some lightsabers somewhere around the office hidden. Yes.
How is it possible that the ChatGPT is not hallucinating when it's getting data from a database?
So the thing is, by giving it a relevant context with RAG, we are essentially enriching the prompt so that it is less prone on hallucinations. If it was on its training data, the fact or whatever we are looking for, it would be harder for it to find, more probable to hallucinate. But if you put it in the context, it is less hallucination prone.
So it's not 100%, it still can hallucinate. But
Yes, yes. LLMs are fuzzy, so we don't know for certain if they certainly hallucinate or not.
do you have any promo codes with free credits for Epify service?
Can you still just always repeat the question?
Yes, sorry.
Short form it can be, but so it's on the recording.
So the other question was, will the RAG prevent hallucinations fully? And now, do we have free credits? Well, we have our stand, so please feel free to visit our stand, and I'm sure they will have some free credits for you.
I have a friend, and he can solve H CAPTCHA automatically. Can he make a business with Epify with this?
I would like to meet your friend. Oh, his friend is solving CAPTCHAs, so that's why I wanted to meet him for the recording.
We can even mention his name on the recording.
Or LinkedIn profile.
Can you simply describe what involves creating a actor in an amplifier? What's the process if I want to create my own? Do you have some proprietary tools or some open language?
Yes, so we have, so the question is, what is the process of building a actor? So we have built templates that you can start from, and also we have open source tooling that help with scraping. It's called Crawly. It's both in Python and JavaScript, so you can choose which one you like. Also, we have the Epify developer tool you can use. You can set up the proxies there and all this stuff. So we have definitely the support on our end. So it's not like you're starting from zero.
Okay.
Since we mentioned about bypassing the CAPTCHA, when you are scraping data from website, you have to bypass the CAPTCHA. So I imagine that it should be part of your workflow, right?
Well, like I said, it's better to not see the CAPTCHA in the first place. That's what we're aiming. But we also have a new team that is focusing on enablement and hopefully solving CAPTCHAs.
How is it about the legal perspective?
So the legal aspect, a great question. So I heard recently there was a lawsuit between Meta and Bright Data, and Bright Data won, so that's good. How they presented their case is that they're not scraping private stuff, they're just scraping whatever is publicly available. So hopefully Meta will not sue us. So I guess that's all the questions. Thank you all for listening to me, and I wish you a great day.